we start the record.
So maybe after do you can tell me the information after the last professor from India?
Yes,
Okay.
yes. I will send invitation to this open lecture. Okay.
Okay. Thank you. And
Okay.
maybe we can first today.
Okay. Okay. If you want, of course. I think we should wait Professor Vasily to connect with us.
Yeah. 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 Yeah.
Okay, but you can show your screen and
Okay. Now, can you see my screen?
yes.
Today, I found some just a bit route about handwritten ticket classification.
Okay, and please wait.
Yeah, yeah.
Okay,
Before Professor Jurgen.
yeah. Uh, Vasily restart his computer. Okay, and okay, Vasily, do you hear us? Please send. Okay, okay. Whom please start, and I think we can connect with Vasily through chat.
Yeah. Okay. First, can you hear me?
Yes, yes, fine.
First, I want to say the code is from the task by Professor Georgin. So today's topic is handwritten digit classification. But I just have a bit route. First, I find some information about Novida SMI. This have some column. The fine is the fine is fan speed, which varies from 0 to 100, so on. And I think, oh, sorry. This code is reprint download listed from internet. Root is a address and chain indicate which dataset is spec field. When chain equal true, we show the chain seat. And the chain equal fields, we show the test seat. I found some information from internet again. I think I have new slides for CNN model. About this code, this code. The structure of the CNN model have this structure. Two convolution layer and two max pooling. And convolution layer use NN point coming to D. Max pooling layer use NN point max port to D. And for connect layer. About this code, after a long time, I found this accuracy can over to 1998 almost. I have a question is from this code, convolution model, this code. If we recharge this number and there, this code will sound wrong. So I mean, if we charge this, then this code what should do to change. Okay, I see. Yeah, you are right. Yes, I want to change input size.
Okay, dear students, please wait 1 minute. Now Professor Vasily will come with my room and we will continue. Okay?
Okay.
Okay. Unfortunately, we have some technical problems for today, and I think all will be all right.
No problem. I wait.
Hello.
Hello, Professor.
Hello. Had some problem with my computer.
Welcome.
Okay. One moment. Yeah. We discussed previously that the model of convolution consists of two parts. The first part, it is a feature extractor, means you use some convolutional layers for getting feature maps. Feature maps looks like images, but they can be changed sized, and it is just a lot of small pictures, and you can describe your image with these small feature maps. And it is a feature extractor. It means that you just process your image with convolutional layers, and you will get some numbers of feature maps, small feature maps. Okay. And after this, you should use classificator. Classificator consists of just a fully connected layers, which can classificate any classes, for example, any classes of image, for instance, male or female, and etc. Yeah. So for this task, you need to transform your small pictures into one-dimensional array like a vector, and after this you can just apply fully connected layers for classificator. So if the size of feature maps changed, means you will get another size of one-dimensional array, because you just flat all feature maps into one dim array. Okay. So, and of course there are some modern methods, some not modern methods, but there are another methods how we can don't change in architecture, and we can use different size of image, and we don't need to change anything in architecture. But in our cases, we need to change the size. It means that we determine size of image, and we preprocess all images to this size, and put in our neural network and classificate any images here. Yeah. So, but in this case, if you want to change the input size, you need to change this part of code. It means that when you transform your feature maps into one-dimensional array, it is necessary transform. So for this task, you need to just calculate how many pixels you can see in feature maps and number of feature maps. So it is just a simple task. You just multiply number of feature maps on height of these small feature maps and width of these feature maps. Okay. So and you will get for this task, for example, 320. Yeah. So but if you change, so you will need to recalculate this number. I understand that it is a very big problem, and in my course we will start discussing with we will start discuss about how the convolutional work, because it is very necessary in data science and our image processing, because you need to understand how the convolutional layer works and how you can get these feature maps from image. It is very necessary task, and PyTorch I guess more preferable for this task, more preferable for these things that we can just showing and understanding how we can get new feature maps. Maybe for the next lecture I will prepare some simple Jupyter notebook where we're discussing how the convolutional neural networks work. I mean that these convolutional layers work, because it is very important for us. So Hun, I hope that I answer for your questions now or not.
Yeah, thank you. This is very detailed.
Just remember that images transform into feature maps. Means you, for example, image like this, yeah, it is like a square image, but you will get smaller feature maps like image, but you have some numbers of these feature maps, and they describe your big image like this. It is a maybe some simple simple imagine how we can just transform our image into feature maps. Of course in computer vision we can use another operation when we restore or okay, how we can recreate image from feature maps. It means that now we just represent our image like a feature maps. Of course, there is another task when we use these feature maps for restoring image again. It is just a segmentation task. For example, if you have some, for example, image with people, yeah, and you want to segmentate people. Oh, okay, this one very good. You can see me, yeah, and you can see some background from me, yeah. And here it is a segmentation task where my silhouette just segmentate. It means that this image transform into feature maps. And after transforming in feature maps, we can use some classification methods and classificate pixels, that pixels it is me or not. And such pixels above me, it is just background, yeah. And it is another task when we can use these feature maps for segmentate image. I get that we will discuss it in my course, but not in workshop design, okay? So maybe in more details how this work. So I hope you understand now what's happened. Okay.
Yeah, okay.
So we can continue,
yeah? If you excuse me, Professor.
Yeah.
If you finish Hong, I have a question.
Yeah, of course.
For my route, that's all.
Okay, I understand. So
Okay.
that sense, and of course, our task it may be global task for us now, trying to train the model for classificate gender, age, and race. Yeah, it is maybe some global task for us for workshop design. And of course, we will start with just a simple task for digits classification, just gender classification. But of course, we can try to implement model for all tasks, and it will be best if you can try to implement this. Of course, there are a lot of problems, yeah, because you don't know how we can use loss function and how we can operate with loss function, but we will discuss it in details how we can do this. Okay, and I see that we just go in step by step and trying to implement any model, and I guess that in the end of the semester you can plot any classificator for image, because this idea will be understandable for you, and using PyTorch or TensorFlow, it doesn't matter. Just I hope that you can understand how the classification image works, and we discuss simple idea how segmentation image works, and we will need to understand about detection, but detection is more complicated, and detection consists of classification, regression task, and sometimes segmentation. Of course, the main goal for us is understanding how the classification and segmentation works, and I will try to get a task with people. It means for people segmentation, people detection, okay, face recognition, and etc. But of course, we have a lot of tasks for medical image processing, classification, and segmentation. But I guess that for you, face recognition will be more fitable. Yeah, more okay. It will be more useful for you. Yeah. Okay, Ali, you want to ask something? Yeah.
Yes, Professor. I talking about task classification age. I have added 5 neural network layers, but I have a problem with the code.
Okay, you can show us your code.
Yes.
Maybe you can send me now in chat, and
okay.
I will try to run it. Okay.
Okay. I show now. After that, I send.
Okay.
Because.
Okay, and just before you're running, while you're running, just ask. Everything is clear on the lecture, Professor Dolganov. You understand the main idea of neural networks?
Yes.
Okay.
Yes, Professor Dolganov always explain about neural network.
Okay. Nice.
Yes. But everything, sorry, everything clear. Just different between design workshop and machine learning just PyTorch and TensorFlow. Just.
Yeah, I understand that. Maybe it is difficult, but of course, maybe in future you will remember me that the best data science should know TensorFlow and PyTorch together, because
Yes.
it is very necessary. I guess
Okay.
the most important framework, TensorFlow and PyTorch too. So, but PyTorch,
now,
I guess, more flexible. Okay.
Now, see my screen?
Yeah, I see. Yeah, we see.
Okay. This same task and list, I run this.
Okay, and here you
Okay.
determine 9 classes, yeah? 9 from
Yes.
0 to 10 classes, yeah? Because from 0 to 8. No, one problem here.
0
0
2
1. But you can see that
0 1 2 3 4 5 6 7 8 and 9.
But you should remember that the maximum age in this data set equal 116. It means that the last class doesn't exist. You can just delete else in class age 9 and just delete these two rows, 2 strings. Okay, this,
just delete this.
Yeah,
okay.
This and this, yeah, because the maximum value is 116.
Okay.
So and now we have 9 classes, 9 from 0 to 8.
Class age 9?
I mean that whole number of classes for these data sets just 9, because you have 0 1 2 3 4 5 6 7 8. It means that whole number 9. It means 0 1 2 3 4 5 6 7 8.
Yes, I understand.
Okay.
But not change. Stay 8.
Yeah. Now is correct. Yeah.
Okay. And go in convolution layer. I run all this code, but one after one. And this code always error. This code. Sorry. This code.
Error. This code error.
Error. I think because now I change all the last lecture. I think don't accept only this.
Okay.
Only
Ali,
this. I change for power 4.
Ali, okay, I see that the main problem here that the last fully connected layer equal 10. Yeah, you just highlighted 10. But
okay. Now 9.
9. Yes, of course, 9.
Okay.
Because you try to classify only 9 classes, and it means that your neural network return output from 9 neurons. Yeah, 9 neurons, and from each neurons you have probability of these classes. Yeah, it means that probability that you have a younger man or not. Okay, and
Now run.
Should be like this. Yeah. So
1 1.
here 4 by
now,
4.
Yes. By 4.
And 4 and yes, below. XView just transform your feature maps into one-dimensional array. Okay.
I think ready.
And
oh.
Is not defined. You need
Yes.
to start.
Run.
And
Yes. In morning to run. Okay, I send you now, Professor.
Yeah, and you should remember, Ali, that for instance, in this notebook, you preprocess your image, means you find face, crop this face, and save this face with size, for example, 64 by 64. But when
yes.
but when you change the architecture, you need to again preprocess all faces and save, for example, for 1052. Yeah. Or yeah, for instance here, just you need to preprocess all image, because now in preprocess folder you collect image with this size, with size 64 by 64, but before start training you need to preprocess all image again. Understand?
Understand.
Because
but
you yeah.
More work.
Yeah, it is some problem of this notebook that you need to always preprocess your image with and preprocess with different size. Of course, in real life, you can use some basic operation from computer vision, and for example, bilinear interpolation. When you have image, for example, 64 by 64, and you can use just a bilinear interpolation for change the size, for example, 252.
Yes.
I hope that maybe Professor Dolganov told you about this, but of course this methods is connected with computer vision tasks, because in computer vision we always use some different methods for changing size of image. Some best practices for better transforming size. But here everything is correct, I guess. Okay, let's maybe we can just look. Okay, everything is good. I can share my screen, yeah? And we just check.
Yes, please.
And we just check 1 moment how we can do this. Okay, screen. Okay, we classify age groups. Okay, let's try. Here we get run. You can see my screen, yeah?
Yes, I see, Professor.
1 moment. I think that okay. So I guess that we need to resize a bit like this. Yeah. So we just run. We will get run anyway. Runtime, change runtime. Yeah, here GPU. Now we just download our data sets. of course, you can use the same technique for other data sets. For example, you can download them from the different sources and use them. Okay, preprocess path, and we can run, for instance, here to. Okay, let's write a bit like this. Sorry, control. How we can comment it. Okay, like this. So, and here we determine the size, your size, yeah, which was calculated. And
Here.
And I guess that here we can. Okay, I don't want to wait half hour here. Yeah. Okay. We just process, for example, 200 image. Okay. 200.
Yes, some picture.
Some picture, for example, 200 here. Okay.
Enough.
And of course, it will be maybe more. It will be better if we can determine, for example, num process, for example, frames here, for like this, none, and we just determine how many frames we want to process here. For example, it will be just a like as a best practice for our task, because for trying we don't need to have all 10,000 pictures. Yeah, we just need, for example, 200 here. Yeah, I hope that it is understand. Yeah, so, and here run, and for instance 100 pictures. Okay, stop. Okay, 88. So let's go. Duplicate data faces, train data, valid data from the process path, and here we just check that everything is correct. Network batch size 64, device CUDA. Okay. And is invalid input for okay, let's see max pool. Okay, the main problem here that this one creates the architecture. Yeah, this one just creating all layers, but the links between layers you need to determine here. It means that you just put your X into convolutional one layer, after him max pooling and ReLU activation, and here we need to add this layer here, 3,
yes.
4, and 5.
Yes.
3,
yes,
4,
yes.
and 5. I hope that this is understandable. So, and
Yes,
now
clear.
everything is correct. Yeah, you can check that you will get the same result. Yeah, you calculate correctly here. Yeah, correctly, everything is correctly. The last layer 4x4, and you have 128 feature maps, and you can see that output shape the same. Yeah, so everything is correct. Now we can check. Okay, let's try. Let's try, and loss now correctly calculated. And here you can see that for Okay, D, it is a input batch, means batch, it is a number of image which will put into our neural network, and the output of oh, sorry, let's write here O shape. Okay, D, it is an input batch which will put into our neural network. The second value, it is the size of target variables. It means that in each for each image we have label, yeah, class of this image. And the last one, it is what's output from our neural network. It means that our neural network return 64 image, and for each classes, for 9 classes, we have probabilities. Means that for each the last layer of our neural network consists of 9 neurons, and each neurons just return a probability of this class. So okay, and loss means loss calculate the error between target variable. It means that what we want to see. If we put, for example, male into our neural network, we want to see the class 0 for example, if 0 class corresponding to male. If we put, for instance, female pictures, female face, we want to see the first class, which is corresponding for female, and the loss function just show us the difference between what we want to see and what return our neural network. And it is a main idea and basic idea that we try to reduce loss. It means that now loss equal 2, but the best way, if this loss will be equal 0. If this loss equals 0 means that our neural network perfectly tell us about class. Means that it is a very, very best answering for each image. Yeah, it means best answering here. But now we just initialized our neural network and we put some photos, some faces, and we will get this value. And this value just show us that we have some problem. We have some problem, but we don't know how this problem significant, maybe because it is just a value. But you should know that the 0, for example, for this loss, of course, for this loss, 0 means that everything is correct. It means that our neural network just very good work for this image. So and of course for calculating loss, you need to compare output from your neural network with your target variable. Target variable, it is a real class of each image. So, and here you can see that if we just run for this phase and the age group of this image equal 4, and of course we can predict some classes, yes, for this image, but of course you will have some problem. Maybe I append new, sorry, where, one moment. One moment where I can see our, okay, previously I add new Jupyter notebook, with for practical work, and I guess it was before holiday, and I append some more detailed information when I get 64 pictures, and I plot metrics with probability for each classes. And you can see that okay, maybe one moment. Okay, let's see. And just one moment. Oh, it is like this, yeah. Okay, it is not probability because I just change a code. I just a bit change the code. Yeah, here is the log softmax. Log softmax is correct way, but maybe not understandable for you now. But okay. Ali, you can just download from the folder task from our Teams group. I append two notebooks for digits classification and for face recognition. Here I add some additional information how we can study our convolutional model, and I just implement some features. You can just see for more understandable how can I get it. Okay, now.
Yes, I send you now. Just a moment. Or I see two tasks.
Yeah, just the two notebooks.
An original.
Yeah, because I delete previous notebook and add new with some additional information, maybe because it is not my computer and I can't.
Okay, now.
So, okay, and now I guess that everything should be correct, and here you just train some model, and of course you will get such training curve, training curve, train and test curve, and you can see that for the first 100,000 iteration, the test curve and training curve decrease together, but after 100,000 iteration, the test loss increased and training loss decreased. It means that you have overfitting because you use the same picture, not the same, you use just the faces, but for this subset your loss increased. Yeah, it is not good because loss should be decreased always, and for training set loss decrease always, of course, because our model and convolutional layers and convolutional models can save some information, because not only mathematical operation like filters, but of course some models on neural networks have memory. And after this iteration, we can say that our model just remember classes for pictures, and when it remember this information, it forgets about other pictures, and you will have some some problems like overfitting. It means that if you get a model, for example, with from this iteration, means you just get weights your model from this iteration, your model will be not good. Better if you just get model from here, because this model not correctly but better solve the task of it is a gender, or I guess that this is a age classification, better solve age classification for both subsets, for test and training subset here, because they are equal. But after this point, you can see that your neural network better solve for training set, but not good solve for test sets. And of course, if you try to get here your model, of course, for test train set is best, because your loss function is equal or near 0, but for test loss is not good, and your loss function is more than on the initial data. Yeah, because here loss greater than on the initial weights of your model. So, and I guess that these points is more preferable for getting this model and using in some service, for instance. Your task is just trying to change, for example, learning rate. You can change number of apples.
Excuse me, Professor.
Yeah.
I send you original task.
Okay, one moment. Here, this one, yeah.
Yes.
Okay, and I just show you my results maybe here. Sorry, not where. I guess that it is not the last.
I think, Professor, yes, not change this task, original.
One moment, I just check how I can go into
yes.
I guess something here. One moment.
Yes.
Files.
Yes.
And here task. And here 5 days ago. Let's look this one. One moment. Download.
The same.
Yes. How it can be? Because I change a lot for better understandable. Okay.
Should we download?
Okay, let's see.
But not here.
Okay. Okay. Remove this and we just file open notebook, upload and download gender. Okay, open. Okay, let's look. I guess that I changed. I have made some changes here. Oh,
No.
Okay, I understand. Thank you. Okay, Ali.
Because I read two tasks, 1
Sorry,
and 2.
It's my fault. I upload this one from my computer, okay? And you just see and try to use my notebook, because I add some additional information for better understanding. With visualization, what we will get from the neural network before training and what we get after training neural network. And I guess that it will be more understandable how it's work. Okay?
Okay.
Thank you for your comments. It is very, very important because I was sure that I upload the correct file. It is very interesting. Okay. Sorry, my fault.
No problem. In next lecture.
Yeah, of course, and we discuss this next lecture. But for you just should remember. Maybe I write in our list task that the main goal now is trying to implement architecture for classificate gender, race, and age together.
Yes,
in one model.
together,
Just
yes.
in one model. It will be now we're just trying to create model for gender, age, and race classification separately, but of course we can use all in one model. For example, it will be more. For instance, if you try to use convolutional neural network in services, for example, some service which predict any information with image, better if you use just one neural networks for all tasks, because you calculate just once and you will get free part of information. Yeah, but if you trying to predict information separately, it means that you always need two neural networks. Yeah, for example, feature extraction and classificator for age prediction, another feature extractor for classification for race prediction, and the same for gender. Yeah, because you need to free model. But our way is trying to create model for all with one model, with one feature extractor. Of course, we need free classificator, but one feature extractor. Okay.
Okay.
Maybe some questions, but of course I will append today new notebooks, and we discuss it on next lecture, next design workshop. But of course, try to understand and just see. Okay.
Okay. Just neural network because I forget added 5. 5 where 5 F really.
Mm-hmm.
Yes, because just 2.
Mm-hmm.
Yes, now clear.
Okay. So
and next week I continue the task,
yeah.
and I think try solution on the task head right.
Okay. Okay. Any questions?
No, for me no.
Okay, of course you can just send me a mail or send me a message in Telegram.
Of course.
Okay.
But now I went to send me task, new task.
I upload it in folder and I send you in our main page in our wall. Okay? That okay. I append.
Yes.
Okay.
That only, and for remember Professor Vasily to upload to record in YouTube 5 and this, because in last lecture no record on YouTube.
I will remember him.
Okay. Thank you.
Thank you too. Okay, Hoon, everything is clear, yeah?
Yeah, clear. Thank you.
Of course, if any questions, just send me email or message, okay? And because it is, I guess, it is like a basis of data science, because if you know and understand how it's work, other complicated architecture will be just like a toys, and maybe you understand how they work, because classification and segmentation, it is important and like a basis of convolutional neural network in computer vision.
Yeah, thank you, reminder.
Okay, so we can finish for today, yeah?
Yes.
Okay. Thank you too, and today I will upload and send you message.
Thank you, Professor.
Thank you too.
Very much.
Thank you too, because it is very useful for me. It is very useful for me because there are some problems with understandable how they work, how the convolutional neural network works, because, and after discussing, I understand where we have a weak problems and other problems. So and I can correct my course and my documents for you, and we can move on.
Yes.
Okay, thank you.
Thank you, Professor.
See you in the next week.
Goodbye.
Goodbye. Bye.
Thank you too. Goodbye. See you next.
Okay. See you later. Okay. Bye.